I'm Csaba Csere, and I'm deep within the bowels of Chevrolet engineering with the new C7 Corvette. A Corvette's a magical car. It's been in continuous production since 1953, and during most of that time it's been America's only true sports car. This C7, or 7th generation Corvette, is particularly interesting because the C6 has been in production for 9 long years, so we're ready and waiting for a brand new Corvette. Let's talk to the guys who can tell us all about it. What were your key goals in the design of the C7?
We wanted to take things that were maybe a little weak on the current car, known weaknesses, and turn them into strengths. Strengths relative to not only other sports cars, but to any other vehicle. Then we wanted to take things that the Corvette has been known for a long time, its power, performance, ride and handling, and actually excellent fuel economy and luggage room, and expand that envelope even further.
Traditionally, Corvette's been remarkably light for its size and power. And was that still an ongoing consideration in the C7?
Well, we've always prided ourselves on being mass efficient. If you look at V8 rear-wheel drive sports cars around the world, you'll find we are the lightest, if not one of the lightest. We've always been a leader in advanced materials, and we're always seeking in every area of the car to keep pushing that state-of-the-art in advanced materials, and the 7th generation is no exception. We've gone to fully customized, engineered, produced in-house aluminum frame. We've got carbon panels on the exterior, on the roof and hood. For the first time on an entry-level Corvette, we've mixed carbon with glass under the skin to lighten and stiffen some of the structural composite. So pretty much everywhere you look on the car, there's been attention to lightweighting.
Well, when I look at the structure of the car, superficially it looks very similar to the previous Corvette, but then when you start looking at the details, it seems like every piece is different.
You're right that every piece is different, and you're right, it looks the same from a distance, and the reason for that is that the load paths that are allowed based on the packaging are essentially the same. People haven't gotten any smaller, you still have to have the occupant space for them. The engine still sits in the front and takes up a certain amount of space. The chassis and suspension parts, likewise. The engine, the fuel tank, the transmission, all that stuff, including space that you want to preserve for the customer for luggage, all that takes up a defined amount of space. You must put the structure in the space that's left over, but none of the tools, none of the parts are shared from either the current steel frame car or the current aluminum frame car. Every single aspect of that aluminum frame has been customized for open air stiffness at a very low mass. As a result, this aluminum frame is 45 kilos lighter than the steel frame of today and almost 60% stiffer, which you can feel every time you drive it.
Now, how do you manage to put an aluminum frame even in the base car?
Aluminum costs quite a bit more than steel. It's a premium material. It requires premium techniques to fasten the parts together. Bringing it in-house helps us so we can control the manufacturing costs. There's been a lot of integration of parts. If you look at what we call the suspension nodes, the hollow castings for the front and rear suspension, you'll notice that compared to today's vehicle where you have a lot of individual stampings welded together, you have a single hollow casting that includes a lot of those different functions, and that saves money overall. But the bottom line is it does cost more to make it out of aluminum. So we've worked on other areas and working with our suppliers to drive costs down so that we don't have to command a higher price for the car.
You mentioned a few carbon fiber pieces. That's another material that we all know is terrific. It's strong, it's rigid, and it's very light, but it tends to be a little pricey.
Carbon fiber is spectacularly expensive. The good news is that the price is coming down. Working with our supplier, we've dropped it to the point where it's just affordable on the base car. It's still about 5 times the cost of an equivalent fiberglass panel, but it is about 1/3 the weight.
Do your customers really appreciate this weight reduction from the technology aspect, or do they appreciate what weight reduction does for you?
Well, of course they appreciate both. They love bragging to their friends. People love to show them off. They like to show how light they are. In very expensive cars, we'll actually use the classic woven carbon and polish it so you can see it. That adds another whole layer of cost on top of the actual material itself. So customers really like that look. They know it's aerospace, they know it's racing. They really appreciate that technology on the car. And then, of course, the way it contributes to the driving experience, they get to enjoy that every day.
Corvette's now been in production for about 60 years. Did the tradition of the Corvette figure much into the design and engineering of the C7?
Well, we're always very knowledgeable and proud of our heritage, and we try to respect that in every way that we can. At the same time, we can't be tied to it in ways that hold us back. So we try not to do a retro car. We've never done a retro Corvette. Make it a Corvette, respect our history, but advance it in every way we can. And that includes use of materials, but also in the appearance of the car, interior and exterior.
Traditionally, Corvettes have almost always delivered on the performance numbers. They've gone fast, they've delivered the lateral Gs, they've even delivered the good lap times. They've maybe been lacking a little bit in just the feel and sort of the way in which they deliver that performance.
Well, you've put your finger on what has been, I won't call it a weakness, but not necessarily a strength of the car. It's the perceived way that the vehicle goes about. You know, it's maybe a sledgehammer. It does everything kind of with brute force. Monster tires and giant engine and, you know, maybe a little bit of brute force as opposed to finesse. So we've spent a lot of time thinking about, from the driver's seat, what does finesse really mean in terms of what tactile feedback do you get from the controls? What is the effort of the steering wheel, the pedals, the brakes? What's the right proportional response? Even though the car is very light, it's perceived as being heavy in some way because of that kind of manhandling way it goes about its business. So we put a lot of effort into kind of those tuning elements so that you not only is the car light, but it actually feels light to drive. The small steering wheel makes the car feel smaller and more responsive. The seat makes you feel more connected to the vehicle so you can feel its every move. We've done a lot of work to move the mass rearward, improve the weight distribution so the car turns in better. We now have an electronic limited slip differential, and when you open the diff, the front end can turn in much quicker.
What about the ability of the Corvette to just cruise effortlessly? I mean, the current car, it's got giant trunk, it gets great mileage on the highway, it's pretty comfortable.
We had to keep that for the customers, and so the trunk room on this Corvette continues with its class-leading standards, so customers can use that luggage room, and also the long-term comfort. You know, it's a car you can sit in all day and cruise effortlessly. Yeah, the car handles really good, but it doesn't have to beat you up to do that.
Over 40 years ago, we saw a mid-engine concept Corvette, and we saw a few others come after that. Yet here we are with the C7, still a front-engine car. Did you consider a mid-engine alternative?
I think every generation except for the first generation, a mid-engine design was considered, and the 7th generation was no exception. We did look at an architecture around a mid-engine and found that it didn't have the good balance of all the attributes that we wanted, that ultimately want to make the best car for the customer. I don't think the Corvette necessarily means engine in front.
And what about pricing of this car?
Our whole business case is formulated around a similar price point. So even though we've added a lot of content to the vehicle, we fully expect that if you can afford a current C6, you'll be able to afford a C7.
So what was your goal in the design of this new C7?
To make the design more compelling, more powerful, but more provocative. We really wanted to lean on some things. We were looking for the front view of the car to be a little bit more aggressive, you know, larger grille opening, just a little bit of a little more seriousness to the headlamps, kind of get, you know, a little bit of a snarl to the front. The body side, you know, here again, more dramatic surfacing, bolder, more gestural side cove than what we've seen before. You know, side coves have been almost vertical on past Corvettes, where this one really leans forward, adding a lot of speed and gesture to the car. And then the back end, you know, we wanted to shake it up and not see the traditional tail lamps going across with the license plate in the middle. So graphically, you know, integrating a plate to the lower diffuser and then giving a whole new treatment to the tail lamps was huge. And then, like I said before, the upper was a big deal too. We really felt we needed a new DLO graphic. DLO is short for daylight opening, and it's your side glass to quarter glass shape. Side glass graphic does a lot to set up the side view of the car.
With the previous car, the C6, you broke away from the hideaway headlights that Corvette has had since 1968. What have you done with these headlights?
We've interjected LEDs across the board. Now we're starting with a bifunctional HID lamp, whereas before we had two projectors. Now we're down to a single projector. So that's a big win for us for as far as, you know, mass and complexity goes. But we've dropped the fog lamp. We've added the DRL and made the DRL the signature appearance item on the front. The DRL is a white LED indirect lamp. Also in the headlamp we've added amber LEDs for the park and turn, and they're basically an edgelit technology.
What are some of the key design details that you're really proud of on this car?
It goes from a dramatic round, convex, concave shape to a very razor-like edge. You know, the contrast between those forms is very extreme, very different for Corvette.
Speaking of aerodynamics, I see several new openings on the car.
Contemporary Corvettes are all about getting a low drag coefficient. We'll talk to a huge reduction in lift on this car as well, but also part of the responsibility of this car is now managing airflow in a different means. Some of the other things that you'll see is that the brake cooling now is integrated into the front grille, into the outboard corners. This is a much cleaner location. You're getting the air off a higher pressure area, so you're able to channel even more air to the brakes. And then the rear quarter inlets is a very new inlet for us on this car. We're actually taking an air to cool the differential and transmission.
So we call this a small block, but it's upgraded from the previous one. What makes this LT1 different than the last small block?
Gen 5 is an all-new design for us. It's a total melt and repour of the small block engine family. It does maintain the same architecture, which is a cam in the block, which gives it a very high power density small package with lots of power. But it also has the same historical 4.4-inch bore spacing. We have very few carryover parts. The two bolts that hold the starter on, a valve spring retainer, the valve spring retainer keepers, piston pin, and the circlips are the only carryover parts from the Gen 4. And for your readers, the Gen 4 was the LS3, which was the base engine in the Corvette. We also have the LS7 and the Z06 and the LS9 and the ZR1.
What would you say are the 2 or 3 key upgrades to the LT1?
The major upgrade really is the direct injection fuel system and the combustion system. You develop a very high performance, optimized combustion system. Direct injection was a big part of that for us, and then we grow the engine around that. So we did a tremendous amount of analysis, over 6 million hours of CPU time spent on developing that combustion system, where we got it to the point where we wanted it so we could extract literally every bit of energy out of the fuel, which is great for making power and torque, and a byproduct is also great for fuel economy. It improves fuel efficiency. So with the direct injection, we also added AFM, cylinder deactivation, cam phasing, which is a first for Corvette. We didn't have that in the LS3, even though we had variable valve timing in some of the truck variants and the Camaro variant. And then finally, we have a very sophisticated lube system. It's a 2-step variable displacement oil pump.
Prime benefit of the direct injection, power or fuel efficiency, or both?
Actually, it's both. What DI allowed us to do was raise the compression ratio. And compression ratio is one of those little magic features of an engine design that if you raise it, it allows you to get better power, torque, and fuel efficiency. So the DI is a big part of that because the DI keeps the combustion chamber cool. And by keeping the chamber cool, we're much less prone to detonation. It allows us to maintain a high compression ratio and not suffer any of the detriments. You heard we're 450 horsepower, 450 foot-pounds of torque, which are our targets.
Did these advanced new technologies add any weight and bulk to the engine?
The high-pressure fuel pump has to generate 2,000 psi's worth of pressure, so it's a pretty stout pump. Its structure, its steel structure is made to withstand those pressures, and that adds some mass. Likewise with the fuel system and the rail, it's capable of withstanding 2,000 psi of rail pressure, and the injectors. That, a cam phaser also that we've added to the Corvette engine also adds some mass. So the engine's mass did go up over the LS3, but we feel it's more than offset by the efficiency gains that we've got in making power and torque and also the fuel economy. That cylinder deactivation system, there's nothing that can touch the brake-specific fuel consumption of that engine when it's in 4-cylinder mode.
A lot of the foreign competitors to the Corvette have overhead cam 4-valve engines. Do you think buyers, at least overseas, will accept a pushrod engine in 2014 in a modern sports car?
And we think the architecture that we have is unparalleled. There are very few competitors in the world today, I don't know any, that has the power density that we have. And power density is our term, and it means how much power does that engine make based on the size of the engine. And if you look at the small block LT1, it's extremely compact. It fits under the hood, a very low hood line at that of the Corvette. Double overhead cam, twin turbocharged double overhead cam, it just would not work. It would not fit. It would not make the car that we want it to be.
What transmissions are you going to offer with the LT1?
Well, the car will be introduced with the automatic transmission, the 6-speed that we have today. It's been revised a bit to be matched very favorably with the AFM system. And also a new 7-speed manual transmission that has 1 extra gear. Highway fuel efficiency is going to be a very surprising fact for our customers who buy this car. When they're in 4-cylinder mode in 7th gear cruising down the highway, they're going to be in for a very big surprise when they see how much fuel economy they're actually getting on the DIC.
Did you face challenges in the refinement of the engine when you're running with this very tall gearing in 4-cylinder mode, and how do you overcome those?
The V8 engine, a 90-degree V8 engine, in 4-cylinder mode does have vibrations. I mean, we know that for a fact because of our history with AFM. But we configure the engine and the firing order and the cylinders we deactivate to minimize that vibration. But the key is making sure that vibration does not get transmitted back into the vehicle where the passenger or the driver can actually feel it and have it become obnoxious. We want it to be seamlessly transparent, so we want him to have 450 horsepower underneath his right foot at his beck and call, and then when he's cruising down the highway, he should know he's in 4-cylinder mode, and our objective we think has been met with all the work that's been done to the Corvette.
It's no secret that two of the biggest shortcomings of the C6 were the interior finish and the seat. What did you do about the interior to make the C7 better?
Well, honestly, when we approached the C7, we didn't approach it as fixing the C6. We really set out to design a brand new world-class sports car. So the interior is all new, the seats are all new, based on a new structure. They're much stiffer, more aggressive than they have been in the past. And there's actually 2 seats available now. So there's a GT seat, which is kind of a great all-around sports car seat, and then a competition seat, which is a very aggressive, more hardcore track-oriented seat.
What did you do in the instrument cluster? Corvettes have had pretty full instrumentation and the option of picking what information you wanted displayed. What have you done in that regard with the C7?
Well, we actually incorporated a 8-inch high-def reconfigurable screen into the center of the cluster. So there's mechanical gauges on either side, but the reconfigurable screen in the center really allows you to tailor the information that the driver is being presented with to their personal taste. There's 3 different modes that you can use. There's a touring mode, sport mode, and a track mode that is actually based on this race car with more of a bar graph tack. Very straightforward, very easy to read.
Does the car remember what modes you've picked, so the next time you start it, it goes back to where you left it?
Yes, it doesn't reset each time. The cluster mode is it's kind of interesting. It's also linked to the vehicle mode. So there's a driver mode knob selector in the car that changes numerous vehicle functions from suspension, chassis, throttle response. And that's also linked to the cluster. So when you go from sport mode to track mode for the vehicle setting, you also go from sport mode to track mode in the instrument cluster.
What sort of optional interiors are you going to offer? You know, some of your competitors like Porsche offer just an unbelievable amount of options.
Yeah, it's very important that somebody who buys this car gets a car that's tailored for them and that's specific to what they wanted. So there's a lot of color availability, and within there's 5 different interior colors. Within each one of those colors, there's a lot of variation in how they are broken up on the interior trim, so you can get a lot of different looks.
How about the central LCD that controls the infotainment?
It's the latest generation of the Chevy Infotainment system, and it has a standard 8-inch touchscreen. But one of the important things with it was we wanted to make sure we had the right balance of touchscreen functionality and functionality in actual hard keys and buttons on the instrument panel. So there are hard buttons and knobs. There's a knob for volume, so you can go deep into the functionality of the screen if you want, but you also have that kind of blind reach capability where you just need to perform a function. It's very easy to reach for it and find it with the hard keys.
Overall, what sort of suspension changes have you made on the C7 compared with the C6?
We know we had relative winner with the way the C6 was set up from a geometry standpoint. We did widen the track width front and rear by about an inch. Basically tried to take weight out of the suspension as much as we could. We knew there was some opportunity, first of all, in the front cradle, which we attach our lower control arm to. We went from a solid aluminum cradle to a hollow aluminum cradle, and that we saved a significant amount of mass there, as well as increasing the stiffness of the cradle. And then we moved out to the lower control arms and took a solid aluminum lower control arm, and we went to a hollow cast aluminum control arm, and saved about 4 kilograms of mass front and rear by just going to hollow control arms. We actually have 3 different suspension levels on the car. There's a FE1 suspension, which is the base car suspension. It's got 35 millimeter Bilstein shocks. about a 26.7 millimeter front hollow stabilizer bar and no rear stabilizer bar. We were actually able to tune that out, so that saves some mass on the base car. And then once you get to the Z51 package, we went the FE3 package, which is the passive shock Z51. It's got 45 millimeter Bilstein shocks on it, with a 28 millimeter front bar and a 26 millimeter rear bar. And then the MR equipped Z51 is the FE4 package, and that's got a 28 millimeter front bar and a 31 millimeter rear bar, and that's got the Gen 3 MR system in it, which is the twin wire dual coil technology, so you're able to ramp in your damping and get the damping out of the shock a lot quicker, about 40% faster than you did with the previous generation MR shock, which is on the C6.
And MR means the adjustable suspension that uses the magnetorheological fluid, is that right?
That's correct. Customer still has the ability to trim the car differently if he wants to by adjusting the tip height adjusters that are on the ends of the springs.
And what about this electronic limited slip differential? What is that and what does it do for you?
It's standard on the Z51 package, and it allows all the systems of the car, so the steering wheel, steering wheel angle, the brake pedal, the accelerator pedal position, the transmission position, all those get fed into a algorithm, and that's sent to a controller, a chassis control module, which feeds information to the actuator for the limited slip differential, and that allows you to be nimble going into the corner. If the car starts to see some instability, the algorithm is set up such that it'll start to send power to that inner tire, and it'll actually help a little bit in understeer to keep the car stable as approaching the corner and kind of in the corner. And while coming out of the corner, if the driver applies some throttle, it'll actually help control his throttle oversteer condition to keep the car going straight.
Are there any brake changes on the C7 compared with the C6?
On the base car previously, we had sliding calipers as standard equipment on the base and the old Z51. We've gone to fixed calipers front and rear now. Brembo supplies all of our brakes at this point. And they're about 12.5-inch rotors on the front of the base car. We go to 13.5-inch rotors on the front of the Z51. We've got bigger calipers on the front as well on the Z51. We've also improved our brake system really with our tires as well by going to the Michelin tires. That there's a lot of technology that was learned from doing the ZR1 tire. When Michelin won the business for the C7 program after a tire shootout, those same group of engineers got with our group of engineers, and they started to develop the base tire for the C6 and the Z51 tire. And those two tires share some of the same characteristics, but the Z51 tires definitely tune more for the track. It's got some racing compounds in it that are similar to the slick tire that Michelin uses.
Any change to the steering system of the C7?
Made a pretty big change. We went from hydraulic power steering to electric power steering, and we understand there's been a lot of criticism of vehicles going to EPS because you lose steering feel, and we're very conscious of that. It was a big debate when we made the change, whether that was the right thing to do or not. But now that we've done it, I actually was just in a C7 prototype with Jim Merrill about a week ago, and I asked him, I said, so what do you think? He's like, the steering system is awesome. It's way better than the C7. And he was one of the guys that really was saying he wasn't real sure about it. It's a belt drive EPS. It's got
is this the ZF system?
It is a ZF system. It's similar to one of our major competitors, their system. It's got a ball nut and worm gear drive, so it's basically an electric motor hooked to a belt drive that's hooked to a ball nut that drives the worm gear, which is on the steering rack itself. And it's low friction, and there's a lot of pitch to the worm gear, which means that you get a lot of, on certain cars you wouldn't want that, but on a Corvette you want a lot of road feedback, and that allows the mechanical advantage of the road, for the road to give feedback to the driver, that correct amount of pitch, and the fact that it's such a low friction joint with being a ball screw mechanism. So you can get a steering setup or a steering tune for the touring mode, and then for the sport mode, and then the track mode, and that can be significantly different. And those tunings are different than the FE3 Z51, which are different than the FE4 Z51.
A lot of valving on the muffler. I remember you had an adjustable sound muffler before, but this one seems to have an additional valve. What's going on with these new C7 mufflers?
Yep, that's our AFM valve. You tune your exhaust system to your engine, and you tune an exhaust system. When you tune an exhaust system for a V8, it doesn't necessarily work real good when you've only got 4 cylinders. This AFM valve actually will close to a certain extent. And this is the valve that's prior to the muffler, and that's on all the C7s, is that valve. That will close in 4-cylinder mode, and it actually, I don't know all the physics behind it because I'm not an exhaust engineer, but that does significantly reduce the NV, negative effects of NV due to 4-cylinder mode. If you compare the base system from the C6 to the base system from the C7, you get about a 13% reduction in restriction. And then the NPP system, the one with 4 valves, is actually about 26 to 27% less restrictive.
Well, you've made, the new structure is substantially lighter, it's substantially stiffer. How do you afford it? Because you look at the C6 and the aluminum structure was only on the high-end cars, the Z06 and ZR1, now you're at the base car. How do you do that?
The big decision was to bring it inside Bowling Green. So when we bring this into the plant, it's a pile of parts, I always say. There's very few sub-assemblies that come into that plant. The most sub-assemblies have small brackets on it, but the entire frame is welded in the Bowling Green aluminum body shop. So that was the number one goal, lightweight, and it turned out to be, stiffer for squeaking rattles, for riding, handling, etc. Everything you do, stiffness. And like Tadge had said, I think, the 2 main areas we did it was, it was convenient to have the hydroform rail. You didn't have to worry about the connections. It was a continuous rail, but the disadvantages are, of course, it's 1 thickness, full length, and we really did struggle when we did the Z06 because up front wants to be a little bit softer for crash worthiness to have a pulse ride down, and in the middle wanted to be stiffer for torsion. And we really had to balance it, and we had to give up on some of the stiffness here. We decided to break it into the 5 segments, take the challenge of the connections, which is really the hard part, and then really be able to customize every segment of the car for what it needs to do. Like the cast nodes, very rigid backup structure for the front crush, and very precise, provides all the attachments, cradles, upper control arms, and shock tower all in one attachment, all in one assembly.
So when we're looking at the front there where the cast section goes into the hydroform rail, how is that joined?
Well,
right
that
there?
axis is MIG weld because that's done in a sub-assembly. So the whole rail is built, the axis in the plant, if you look, very automated. They build each rail, left and right hand rails have their own substation. They build them up with the 5 pieces, put them in the tools, they MIG weld both front and back on either end, and then they carry them over to the main line.
Since the C6 was introduced, it was 9 years ago, there have been a lot of new crash standards, some of them official, some of them the aftermarket kind of testing, like the offset crashes. How do those figure into your structural considerations?
We could not re-engineer the Corvette structure, would not pass all the new regulations. Additional offset requirements, IHS requirements, internal standards. So we go through a battery of tests. I don't know, well over 20 high-speed tests, front, side, rear. And actually it's just, we have analytical tools. We estimate where we have to, where we have to put the metal in the structure, and then we do our analytical tools, and we crash test.
But is there any maximum, or stiffer is always better?
We started saying we're going to be as good as C6, and that's a pretty good car. And it was 3 times stiffer than, C5 was 3 times stiffer than C4, C6 and C5 were very comparable. And we said we're going to hold it. But once we got in the car, I think, Jim Merrow and the ride and handling team and Tadge felt we just weren't as stiff as we need to be. But it's always a balance. We could have made this 90% stiffer, but we would not have got 99 pounds out of it. So it's really a balance between stiffness and mass, and it's always been what's good enough but not too much.
What do Corvette customers expect from the new C7?
That they want a no excuses car. They want everything to the highest level. It's not enough anymore just to hit the numbers, to hit the performance numbers, which we're going to do, and always improve the performance. But it's about the things you can't measure. It's about the way the car feels, the way the car makes you feel when you're driving it, the attention to detail, the ride, the handling, but the things that may not be ever measured on a stopwatch.
How many of your customers actually take their Corvettes to the track?
The majority of Corvette drivers will take or have the intention to take their Corvette to the track one time to really experience what the Corvette is like on the track. Because the way to experience the performance, you really have to.
Well, what new audience would you be going for with the C7 Corvette?
We want to go after people that study sports cars, people who are enthusiasts, people that do the homework to know what sports car is the best. They may not be so brand loyal, that's not just searching for the best badge, but is searching for the best sports car. And it could be at any price.
A lot of car manufacturers claim that their sports cars use race-derived technology. How do you intend to drive that message home to customers with the C7?
When you look at the exterior of the car, a lot of people may think, oh, here the vents on the car, they look cool, or we did them because they look cool. But you can see, if you look at the Corvette race car, you can see the direct influence from track to street, how these are devices that help reduce the lift of the car or increase cooling to the transmission or the axle of the car. The brakes, the way we've scored the brakes is from learning from the race car. So there's visual things that the customer can immediately see.
That's a pretty comprehensive look at the hardware and design of the new C7. Since 9 years have gone by since the last Corvette, we expected a comprehensively redone car, and I'd say we got one. We'll be driving this new car in the early part of the summer, and it'll go on sale in the fall. Until then, this tantalizing information will have to do. I'm Csaba Csere, and I'll see you next time.